a perfect square. And sometimes I think that gets confusing because we talk about it completing the square. But in reality, what we're doing is creating a square. We're creating a binomial squared. So when we had that, the thing I want you guys to notice about creating a square is, yes, the first and the last two terms have to be square numbers, right? But the middle term has to be, remember, it has to be a product of 2 times x times y, right, to get that middle term. And that doesn't work here. So this does not equal x plus 2 squared, because when you multiply that out, you don't get to 6. So what we're going to do is we're going to create a perfect square trinomial. So to do that, we are going to group the first 2 terms together. OK? I basically have my ax squared and my bx. So this is in standard form. Now, to complete the square, your first term has to be a square number. And your last term has to be a square number. So I have x squared. Is that squared? Is that a square term? Yes. I need a constant, though, that makes a square term. So what I'm going to do to create, because 4 doesn't work, so I'm just going to take it on the outside. So what I need to do is I need to create a number. So what I'm going to do is I'm going to take b, which is my coefficient of my x, divide it by 2, and square it. 6 divided by 2 squared equals 9. OK? And I'm going to take that 9, and I'm going to enter it inside the parenthesis. OK? Now, when I take that 9 and I enter it inside the parenthesis, now what I have done is I have created a perfect square trinomial. Do I have a perfect square trinomial that's very similar to that one? Look on the board. What's the only difference? Positive, negative, right? But you guys know this is a perfect square trinomial. You don't need to use a diamond method, box method, all these factoring techniques. When you complete the square, you create a perfect square trinomial every single time. So you don't have to worry about factoring. You know this goes to a binomial squared. Every single time it goes to a binomial squared. Now, the one mistake we have is you can't just add something on one side of the equation. When you do whatever you do on one side, you have to do on the other side, right? But in reality, guys, if we want to solve for y, we're going to be subtracting a 9 anyways, right? So instead of adding a 9 on both sides, when we're writing it in Vertex form, I just prefer to add and subtract. OK? Adding and subtracting is really the same thing as adding on both sides. OK. Now let's simplify this. So this is x, middle term is positive, plus 3 squared. 4 minus 5 is going to be a negative 5. And there you go. Now it's in Vertex form. Magic. OK, now let's go and identify the vertex, h and k. So I say my vertex is negative 3, comma negative 5. My a, which is a positive 1. So therefore, my graph opens up. So therefore, this is a absolute min. OK? Yes? Sure. 3 equals 3, right? Good. So you could also say, like, you could also add a 1 to both sides, and it still equals, right? Or you could subtract 1 on the same side. Add 9, subtract 9.
Yeah, but why would you do that?
Well, you have to. This is not a perfect square trinomial. This doesn't look like one of those. So you had to find the number that creates the perfect square.
So you added that one side.
So when I added inside that, that creates the perfect square trinomial. But you just can't add a number to an equation and say it's good. You have to counteract it by subtracting the 9. OK? All right.